Hi, thanks a lot for being here. So I'm going to present this work, Redistribution through Market Segmentation, which is a joint work with Victor, which is just right here in the room, and Daniel Barreto. So I think I don't need to convince you that more and more data about consumers is being collected by different websites and platforms. And one possibility with this data that has attracted attention from economists is to use them to charge personalized pricing or to implement price discrimination. And the tools to do that is market segmentation. So that's what I will refer to in this talk. And in this paper, we look at the use and the consequences of this tool to implement redistribution among the consumers. But first start from the beginning, what do we know about the consequences of price discrimination or market segmentation on total consumer surplus? So of course, we know it can be very negative, it can be detrimental. The extreme case being first-degree price discrimination, where every consumer pays the maximal amount they are ready to pay and they make zero surplus. But more interestingly, we also know that it can be beneficial, and it has been clear at least since the work by Bergman, Brooks, and Morris in 2015. And how do you generate surplus and transfer this surplus to the consumers? You basically create market segments where you pull consumers with high willingness to pay with consumers with low willingness to pay in order to drive down the prices and allowing the consumers with the high willingness to pay or type to make some surplus. So indirectly, basically the lower types, they exert some forms of positive externality on the higher types consumers by allowing them to obtain strictly positive surplus. But indirectly, even though you want to maximize total consumer surplus, you also define how this generated surplus is going to be distributed among the different types of consumers. And importantly, you are indirectly mostly benefiting consumers with high willingness to pay, which arguably can be thought as like being, on average, richer consumers. But that's basically the question of this paper. What if we actually care about how this generated surplus is going to be distributed among the different types of consumers? And more specifically, what if we want to prioritize lower types consumers, lower willingness to pay consumers, or consumers that make lower surplus, this is what I mean here by redistributed. And I will be clear in a couple of slides. So just as a very teaser, basically redistributive segmentations will exhibit positive assortativity, contrary to the ones that maximize total consumer surplus. And as a consequence of this, some of the generated surplus will be transferred to the seller. So basically, we'll give a redistributive rent to the seller, an additional profit, compared to the case where there is no segmentation. So not all the surplus will go to the consumers. I will be clear about it in a couple of slides. So let me lay down the basic framework. So for those who are familiar with Bergman, Brooks, and Morris, the basic setup is the same. You have one monopolistic seller, and you have a unit mass of buyers, each of whom can consume at most one unit of this good. So the buyers are just described by their willingness to pay. I will refer to as the types. The types can take a finite number of values from the smallest one, θ1, to the highest one, θn. And basically, they consume the good at price P if and only if this P is lower than their types. So regarding the seller, we normalize the marginal cost of productions to 0. And the only action here that the seller is taking is setting prices. Okay? Whenever they face a market or a certain compositions of consumers, they just set a given price for this market. So the tool that we're looking at here is market segmentation. So there is a designer here that can design market segmentation. What do I mean by this? So you have an aggregate market of consumers, U, which is distributions over the types. So it's basically my compositions of my pool of consumers in terms of different willingness to pay. And a market segmentation is just the divisions of this aggregate market into some sub-markets, market segment, in each of which the seller can charge different prices. Okay, so let me just say straight away, it's basically a Bayesian persuasion or information design problem. But I'm not going to adopt the belief-based approach. I'm going to consider segmentation as being a direct recommendation mechanism. So let me illustrate this on this grid that I will use during the whole talk. So this grid has, in the x-axis, the types, and in the y-axis, the prices. It happens that the set of possible prices is exactly the same as the set of types. Okay? If you don't see it right away, just believe me, but if you think about it, you're going to see why it's the case. And so I can write down here my aggregate market, okay? So behind each of these dots, there is the mass of each type. So it must sum up to 1, okay? And I put it at the line theta star because theta star is my uniform price. It's the price that would be charged if there is no segmentation. So now the segmentation is just a splitting of this line into some other lines, okay? So different market segment, each of which is determined by the price that is charged in this segment, okay? So the requirements, the two requirements for this direct recommendations mechanisms to be feasible, the first one is that for each given type, I allocate a given mass of this type to the different segments. So it must be the case that when I sum up the mass behind this dot, it must be equal to the aggregate mass of consumers of type theta. It's by exclusivity constraint if you want. And the other one is must be obedient. So given the assignment of the different types into the different market segment for a given market segment, here P prime, it must be the case that charging P price is optimal for the seller. It's obedient mechanism, right? So now let me tell you a bit more about what I mean here by redistributive preferences. So I'm going to define preferences also on this grid. Okay, so W of theta P is the individual contributions to social welfare of a type theta that is assigned to a market where price P is charged. So in this paper, we consider a large class that we call the redistributive welfare function. I'm not going to give you the details of this class. The key aspect is supermodularity. But I just want you to think of two standard examples of welfare functions that fit into this class. The first one is, suppose you are basically a weighted utilitarian. So you maximize the weighted sum of the surplus, okay, where the weight lambda of type theta is decreasing with the type. So that's the redistributiveness aspect. So the idea is that types are like kind of positively correlated with wealth more, and that you actually value more poorer consumers. Okay? Has been used quite extensively in some recent papers. The other quite natural things, social welfare functions you can have in mind is just a concave transformation of the surplus, okay? Decreasing marginal surplus. All right, so here the value of theta P is just U of the surplus, where U is a concave function. I just want you to keep in mind the weighted utilitarian for the rest of the talk, but just bear in your mind that all I'm going to say applies to a much more general, and I don't need the linearity assumptions in this weighted. So before showing you some of the main results, I need a preliminary result that I call like no exclusion. It just says that it's without loss of generality to consider segmentations that do not exclude any consumers. In other words, segmentations that are only supported on the lower right triangle on my grid. Okay? Lower right triangles are all the pairs of types and price such that the types is greater than the price. Basically, all the dots where there is consumption. So I can basically be sure that I never exclude consumers. In other words, it's an efficiency result. I can restrict myself to efficient segmentation. Generally. So I'm going to denote theta star of mu this set of segmentations that do not exclude any consumer. All right? So here is the first exercise I'm going to do. Start from a given segmentation, efficient segmentation sigma. The question I'm going to ask is like, which modifications I can make on this sigma that are unambiguously good, in the sense that they would increase any redistributive objective that I may have on my consumers. Okay. So start from a given segmentation here. I have a given efficient segmentation, so supported on my lower right triangle. So there are at least two very natural candidates. First, if I can, I'm going to call it downward mass transfers. If I can move some consumers who are paying high price to a segment where lower price is charged without breaking obedience constraint, I will be always happy. I want to benefit consumers. Okay. But that's some downward mass transfers. And the other one is related to redistributiveness, is if I can switch consumers of low type paying high price with consumers with high types paying low price, if I can switch them, swap them without breaking obedience constraints, I will always be happy here. That's the supermodular that lies behind. So it turns out that actually these are the only things you should care about. It's the only things that really matters. And to make it precise, we show this following theorem. We characterize an order over the set of segmentation, which basically says the segmentation sigma primes performs better than a segmentation sigma for any redistributive objective you may have. Okay, so it's more redistributive than if and only if sigma prime can be obtained from sigma by a finite sequence of these mass transfers without breaking obedience constraint. Okay, so in other words, if I start from a sigma, I can unambiguously improve the sigma if and only if I can find one of these two transfers, which are pretty simple transfers, without breaking any obedience constraint. Right? So thanks to this order, we're going to obtain some qualitative characteristics of on the optimal segmentations, which is what I'm going to start saying here with the first result. So now X is a redistributive objective W in an I class. And I'm going to say that any optimal segmentation must be weakly monotone. So that's the notion of positive assortativity here. So let's not necessarily look about the formula, let's just look about the graph. It basically says that for a lower price segment, the maximal type that is in this segment must be lower than the maximal type in any other segment paying higher price. Okay, so basically, they are not only ordered, my segments are not only ordered by their price, they are also ordered in the same way by the maximal type. Okay, it's from forms of positive assortativity. There are some binding constraints in addition, not enter into details. Yeah.
So is it easy to summarize what, like you said, there's some supermodularity, just this class R, is it easy to summarize what are the conditions to be in R? Or at least what are the conditions?
Yeah, it's easy to gain time. Think of basically these are any increasing transformation of the surplus where supermodularity is satisfied.
Okay.
Okay. So it's 0 on the upper left. It must be decreasing with the price on the lower right, and it must be supermodular. These are my class.
Thank you.
All right. So I can strengthen these notions of monotonicity quite a lot. So here I'm going to state this result for the weighted, but we have a general result for any functions in our class. So remember, I have a weighted sum of the surplus where the weights are decreasing. And here I'm going to strengthen this notion of monotonicity for functions that are sufficiently strongly redistributive. Okay, so in this case, it basically means what? It means sufficiently steep decreasingness of my weights. Okay, so this is stated in the following way. So for any functions like this, there exists a kappa, such that if the ratio between two consecutive weights is greater than this kappa, okay, then my optimal segmentation must be strongly monotone. And this means the following thing. It means that for a lower price segment, every type in the segment is lower than every type in the segment paying higher price. Or in other words, basically my optimal segmentation will very simply like partition my set of types, where the bulk of the lower types pay a low price, then the second bulk of types pay a higher price, and etc. And they only maybe have, they have intersections at the boundary. So one thing that is pretty good with this, it gives an extremely simple algorithm to construct such segmentation. Because basically, I just start by like pushing as much as I can of lower types in the low price segment until I basically bind the obedience constraint. So I cannot pack more of a certain type of consumers without breaking the obedience constraint. I close this segment and I start a new one with the remaining guys of this type, and I do it again. Okay, it's very simple to design an algorithm to get this segmentation. And so the last thing I want to talk about is these notions of what we call redistributive rates. So as I said a bit in the introductions, it might be the case that when you want to do these redistributive segmentations, you start giving additional profit compared to the uniform case to the seller. So basically, I'm going to say that the market mu is a rent market if under a sufficiently strongly redistributive objective, optimal segmentation will start giving additional profits to the seller. Okay? We denote like big gamma the set of rent. So let me just introduce this segmentation. Segmentation just divides my set of types into two segments. All the guys below my uniform price are packed in a segment where they pay the lowest price. And then the remaining guys above my uniform price are packed in a segment where they still pay the uniform price. Okay. So here it may not be feasible. Okay. But if it is feasible, it's the unique strongly monotone segmentation that does not give any additional rent to the seller. Okay. So then with this segmentation in mind, it's pretty easy to characterize. Basically says that first, it's a non-empty set, the set of rent markets. Okay. And the market is such that I will give rent to the seller for sufficiently strongly redistributive preferences if and only if I can never implement this segmentation. Right. if and only if this is never feasible. Another consequence that it has is that suppose that my market mu is not a rent market, okay, meaning that this is a feasible segmentation. Not only it's good, it also means that it's the unique optimal segmentations for any redistributive objective you may have. And it's a pretty simple segmentation. It's just create two segments, one with lower price and one with uniform price. And it basically serves all the guys that were not served before with a low price and serve the guys that were served initially with the same price as before. Okay. All right. So let me summarize what I've just said. So basically, we first characterize this redistributive order, which on the space of segmentation. We just said that a segmentation performs better than the other for any redistributive objective that you may have. And we characterize it in terms of like simple mass transfer, elementary mass transfers of tiles. Thanks to this, we are able to show that distributive segmentations feature some quite nice characteristics of monotonicity, some forms of positive assortativity, which goes in contrast with like the ones that maximize total consumer surplus that rather exhibit negative assortativity. Kind of elaborate the fact that these segmentations may give some surplus to the seller, additional surplus compared to the case where there is no segmentation. And so transferring part of the generated surplus, not all to the consumers, but some to the seller. And I did not talk about it today, is that here I kind of made a very normative high-level exercise where you like basically control any segmentation, but it happens that you don't need to have such a big power. You can actually implement this redistributive segmentation if you let the platform or the seller choose the segmentations, but you regulate the distribution of our prices that is induced by this segmentation. Okay, so basically, it's implementable with a price-based regulation. And